Artificial intelligence, or AI, is truly a revolutionary feat of computer science, set to become a core component of all modern software over the coming years and decades. This presents a threat, but also an opportunity. AI will be deployed to augment both defensive and offensive cyber operations. Additionally, new means of cyber attack will be invented to take advantage of the particular weaknesses of AI technology. Finally, the importance of data will be amplified by AI's appetite for large amounts of training data, redefining how we must think about data protection. Prudent governance at the global level will be essential to ensure that this era-defining technology will bring about broadly shared safety and prosperity. Welcome to AI Insights. Subscribe now so you never miss out on any of our latest uploads. Okay, let's get into the video. AI and big data. In general terms, AI refers to computational tools that are able to substitute for human intelligence in the performance of certain tasks. This technology is currently advancing at a breakneck pace, much like the exponential growth experienced by database technology in the late 20th century. Databases have grown to become the core infrastructure that drives enterprise-level software. Similarly, most of the new value added from software over the coming decades is expected to be driven, at least in part, by AI. Within the last decade, databases have evolved significantly in order to handle the new phenomenon dubbed big data. This refers to the unprecedented size and global scale of modern data sets, largely gathered from the computer systems that have come to mediate nearly every aspect of daily life. For instance, YouTube receives over 400 hours of video content each minute. Big data and AI have a special relationship. Recent breakthroughs in AI development stem mostly from machine learning. Instead of dictating a static set of directions for an AI to follow, this technique trains AI by using large data sets. For example, AI chatbots can be trained on data sets containing text recordings of human conversation collected from messenger apps to learn how to understand what humans say and to come up with appropriate responses. One could say that big data is the raw material that fuels AI algorithms and models. The main constraint on innovation is no longer the difficulty in recording and storing information, but the finding of useful insights among the sheer abundance of data now being collected. AI can notice patterns in mammoth data sets that are beyond the ability of human perception to detect. In this way, the adoption of AI technology can make even mundane and seemingly trivial data valuable. For instance, researchers have trained computer models to identify an individual's personality traits more accurately than their friends can, based exclusively on what Facebook posts the individual had liked. AI and cybersecurity. Hardly a day passes without a news story about a high-profile data breach or a cyber attack costing millions of dollars in damages. Cyber losses are difficult to estimate, but the International Monetary Fund places them in the range of $100 to $250 billion annually for the global financial sector. Furthermore, with the ever-growing pervasiveness of computers, mobile devices, servers, and smart devices, the aggregate threat exposure grows each day. While the business and policy communities are still struggling to wrap their heads around the cyber realm's newfound importance, the application of AI to cybersecurity is heralding even greater changes. So, one of the essential purposes of AI is to automate tasks that previously would have required human intelligence. Cutting down on the labor resources an organization must employ to complete a project, or the time an individual must devote to routine tasks, enables tremendous gains in efficiency. For instance, chatbots can be used to field customer service questions, and a medical assistant AI can be used to diagnose diseases based on patients' symptoms. In a simplified model of how AI could be applied to cyber defense, log lines of recorded activity from servers and network components can be labeled as hostile or non-hostile. And an AI system can be trained using this data set to classify future observations into one of those two classes. The system can then act as an automated sentinel, singling out unusual observations from the vast background noise of normal activity. Implications for policy and governance. These unfolding developments will force a rethinking of prevailing cybersecurity strategies. In an increasingly interconnected system, identifying the weakest link becomes more challenging, but also more essential, as sensors, machines, and people become interwoven providers of data for valuable AI systems. There will be a proliferation of entry points for cyber attacks. Cybersecurity requires a comprehensive strategy to minimize weakest links. A piecemeal approach to cyber policy will not work. Since the training data that feeds the most important and revolutionary AI technologies is global in scope, gathered from across many different countries, it is clear that governance at the national level alone will not suffice. Okay, that's it for today. If you enjoyed this episode and you found it helpful, don't forget to give us a thumbs up and to subscribe to our channel for more content just like this. Well, thanks for watching, and we'll see you again in the next one.